Hello folks. So now trying to get the CNC lathe to do some work, and it is now ready for work. I have solved a number of problems with this lathe, and now I want to share what I learned with you so that you don't have to do that much learning as I had to. So this video will be about aligning the turret of this Dainichi BX45 lathe. So it's a 1985 Dainichi BX45, and I think it's the same as B45 and also some other models. So basically when I got this lathe, almost from the beginning I knew that it had had a pretty bad crash, which probably has something to do with this U-drill, which is just a slight bit of damage, as you can see. So this has been plowing into the workpiece and welding itself and drawing sparks and everything for a good while, and most probably this has caused some issues in the lathe. I got this tool with the lathe. It was still sitting in its holder. So this lathe has been a crash, and I think at least every older CNC lathe has been in numerous crashes probably, and there will be some alignment issues. And of course first you have to measure if everything is aligned, and if you find error you must find out where it's coming from. One of the worst case scenarios is that your headstock is out of alignment. It's pretty easy to align just by loosening some bolts and adjusting set screws. I didn't have to do that. My spindle, my headstock is straight, no problems with that, but the tailstock, I mean the turret, was pretty badly out of align. And how I figured this out is by indicating these ground surfaces on the turret. So each of these faces take a tool holder. So first you can indicate the bottom like this, and that will give you the axial alignment of the turret. And if it's off, it can be adjusted by loosening these 3 M12 screws, and there are 3 more under this cover. I just put it back, but you can see them when you take this cover off. One of them is in a pretty nasty spot, and I actually left that bolt tight on my lathe, and I was still able to do the adjustment. To do the adjustment you have 2 set screws, one here and one here. So in my case I just had to push this one up after loosening these. And something very important is to remove these taper pins right here, because of course when you have the pins tightened, you cannot adjust anything. And I think there are many opinions on whether or not to put the pins back in, but I think it's not a good idea to put them back in, because things will never be perfectly aligned again when the machine is crashed badly for the first time. I still have to clean this wheel wiper, by the way. So just pull them out with a slide hammer, and then just keep sweeping these faces. And also you can try to sweep this face right here. This is actually even better, by moving the x-axis up and down and having an indicator, for example, right here in the in the headstock, and then just slowly adjust these head screws right here until you get no error. And then the second type of adjustment that can be off, and which in my case was off, is the radial adjustment of this turret. So in other words, when you sweep a boring bar holder like this, the indicator should be not moving at all. So it should be on the center, with the lathe spindle. And mine was off radially like this. So what I had to do is to basically loosen the curvy coupling on one side, and then tap this into place and then retighten the coupling. And also there I had to remove taper pins. So how I did this: first you have to take off this cover right here. It's just on with 4 M8 screws right here, and it comes out just by prying with a screwdriver against these bolts. And this is just, by the way, a stop for these tools, and it's also holding this badge with the tool numbers, so that's very easy to get off. And behind that you will see bolts attaching this turret to the main axle, the shaft of the turret. And you have to loosen them as well, because you do have to take off the turret to be able to loosen the curvy coupling screws. So let me show the exploded view to you. Maybe this is more clear. So right here is the turret, this is the turret, and this plate right here is the curvy coupling on the turret side, and right here is the curvy coupling on the frame side. And this is the shaft going through it, and here's a flange, and this is one of the bolts that's holding the flange of the shaft to the turret. So I think there were 6 bolts tightening the flange to the turret, so you have to loosen them all, actually take them all off. And then there were also 2 taper pins which you have to pull out. And then carefully, actually before you take off the bolts, switch off the controls, which also switches off the hydraulics, because otherwise this shaft will be pulled in, trying to tighten the turret like it should be. But when you have the hydraulics off, it shouldn't pull in, at least as much as when it's on. So when you have the hydraulics off and you have all the bolts off and the taper pins off, the turret will come out by just prying, for example right here, and doing the same thing on the other side as well. There's a huge O-ring seal which is resisting a little bit, but it will come off with some persuasion. It's not easy, but it will come out. And be sure to, for example, leave 1 extra long bolt in the shaft flange, so that when you get it off, the bolt will be still supporting the turret and it doesn't fall on your feet, because the thing weighs like 50 kilos or more than 100 pounds. And be careful with it. And when you get it off, you will actually see the curvy coupling on the turret side and the other side on the base. And what I did, I actually removed or loosened the bolts on the base side, because they came out easier. And actually how you do the adjustment, or how I did it, was by leaving 4 of the 8 screws on and only putting moderate pressure to them, moderate force I mean, or moderate torque. And what I did then, of course I removed the taper pins as well from the curvy coupling, because they are no good anymore. And then with the 4 screws and no taper pins, I put it back, and as I told you, I only put moderate force on the screws, and then I put the turret back on, and then I swept the inside right here, and it was still off, so I used a soft hammer to tap right here. Because the screws on the curvy coupling are loose, I was able to spin the turret. And you have to be very careful when you take it off again to put the rest of the bolts back and tighten them all. Because when you, if you accidentally knock it when you remove it, the adjustment will be off again. So be very careful when you take it off again. So, in other words, to be able to adjust the turret radially, you have to remove the turret, which kind of sucks. So, and of course you have to make sure that the tool holders are straight, are sitting straight on the turret faces. So, and where I got a huge amount of information about this job is from Wes Johnson's YouTube channel. Let me show you. If you are doing a job like this, check out this guy. He has a complete 4-part series on aligning a CNC lathe. Check this guy out. Even if you don't have a CNC lathe to align, check out his videos. It's very good entertainment. He's a very good guy. Mechanically, and also he's very good at explaining things, unlike me, and also he has some pretty good machining videos. So this video series is a must to watch if you work with CNC machines. This machine was easier than mine because the curvy coupling was screwed on by these screws right here, so they were actually accessible without removing the turret, which would have been very much easier than in my case. But he did just the same, so he swept one of the boring bar holders, having these bolts loose and the taper pins out, and then he just tapped it to center and then tightened these bolts. But you cannot do this on the Dainichi lathe. You have to take off the turret. But it really isn't that bad. But you need to have 2 people because it's too dangerous to do it alone because of the weight of the turret, or at least you have to have a crane. And of course, I think all of you know this already, but if you sweep the holder and it's off in this way, I mean up and down along the x-axis, that can be compensated for by programming. So actually what you do is you reset the machine so that you have everything zeroed, and then you manually jog the x-axis to where the indicator is showing 0, showing no movement, and then you check the machine X value, and right here you check the machine X value when you have no run out in the indicator, and then you go to offset and work 0 offsets and enter that value in the 0 shift right here. So this was my X value. Okay, so it's that easy. Okay, so, and why this is important? It's important because if the axial alignment is off. It's not that bad on OD turns, on OD turning tools, and even not so bad on ID boring bars. But when you are drilling, it's really bad, because the drill might be somewhat on center right here, but if it's a long drill, it will go more and more wrong the longer it is, and you will get bad tool life from your drills and bad quality holes. But when the adjustment is off radially, what's gonna happen is all of your tools will be offset, off center I mean. So all of these OD and ID tools, and also drills and boring bars and everything will be off center. And in my case the offset, I mean the error was about 0.5 millimeter, which is just too much for drilling. So some error you can compensate by leaving out these pins and just tapping the holders, but that's not a very good way to go. So, and even after adjustment, I had to use a little bit of shims under one tool right here. The other tool that I have in now is sitting fine as it is, but these tool holders are old and worn, and they've been repaired by welding and everything, so there's some error in them. But I think the turret alignment is now pretty good axially and radially, and that's how it should be. So, and one more thing about the turret. The coolant comes about here. You have a big hydraulic hose coming here, and then it goes through a bore right here, and when you open this you get coolant out of it if you like to, and then it goes right here and goes to the turret by this little rubber thing. So the coolant is not transferring through the shaft, but it's going right here. Let me show you how it works. So there's just a rubber seal that's sealing the coolant. Just because I was wondering where the coolant comes to the turret, and that's how it is. And you can actually, if you have coolant problems, you can try spraying some compressed air in the coolant nozzles on the tool that you are using. So when you spray compressed air here, you should hear the coolant bubbling in the tank. If not, you have a clog somewhere in probably in this area. Okay, I think this is now long enough. I really hope if any of you have this type of lathe that this helps you. If I had seen this before, it really would have helped me, because my issue was mostly that looking at Wes Johnson's video, I just couldn't think of why the Japanese engineers would have made the curvy coupling so that you cannot adjust it without removing the turret, but that actually was the case. So I just needed a little bit of encouragement, and I also encourage you to do that if you have to. It's not that bad, and if you have any questions, please ask me. I will do my best to help you. Okay, and next to come is a video about setting work and tool offsets on this lathe, because it was also very difficult for me. So I'm sharing it to you, and also to remind myself if I ever forget how to do it. So thanks so much for watching, and the best of luck to you with your Dainichi lathes. And please subscribe to Wes Johnson.